So this is a Raptor drive inside of a YVAA air-cooled chiller. The initial complaint was the fuses were popping, as you can see them there, and that the main breaker was also tripping down in the mains. So came out here, confirmed the reactor was good. Started at the inverter gates, worked my way back through. Inverter gates tested a little weaker than I normally would expect them to see them. These capacitor banks are also reading weak, and we had this bad boy split open. You can see it kind of bubbled some goodies out there. So once I went through the capacitors, I came back up here to the SCRs, and sure enough, I've got two gates here on each of these on the end that are not working, and then this middle SCR has a gate that is shorted out internally. And so I think the problem probably started here and the rest followed suit after that. Anyway, I'm gonna price it to rebuild it. It's been rebuilt once before. I could tell by looking at it. All of our snubbers were good, but I think it's, given the extent of the damage here, it's probably going to be cheaper to possibly just replace this entire drive assembly. So we're going to get with the manufacturer and see what we can get worked out for the customer. Alright, so we're changing out this refrigerant sensor, letting the binding view on the tech view link up. So this refrigerant sensor is reading a little off, and it's causing it to register a higher approach value, even though it's actually not. Well, I say a high approach. It's not reading a high approach, it's reading a negative approach. It's saying I've got a negative approach of a few degrees, and that's completely bogus. So this sensor has gotten out of calibration, so we're going to get it changed out and see how she does. So I want to explain one of the reasons why that's so important is if it can't read its saturation temperature correctly and monitor its approach, that's how it's controlling the safeties, where the safeties are, and when the safety limit needs to cut out at. That's how it controls how much to load or unload based off leaving water temp. And it's that refrigerant saturation on the evap plays a big factor into the efficiency of this machine. So whenever you do not have that temperature reading accurately, it's going to give you a lot of problems down the road. Especially the customer is going to see it in a lot of loss of efficiency, because the machine thinks it's operating in a completely different state that it is. So those sensors ought to be very close to on point. It may be, I usually don't like to go more than a degree and a half of tolerance. I don't remember exactly what the manual says off the top of my head without looking it up, but those need to be very, very, very close within. So and keep in mind, anytime you change these sensors, you've got to use TechView, and all of these sensors are communication data based. So you've got to be able to link it and unlink the old sensor and link the new one, bind it in, as they call it, the train. So it's not as simple as just doing a switch out. So that's it, guys. Well, that took care of that. So we were floating between 2 to 4 degrees of approach, negative approach before, which should not be possible. And now we're floating between half a degree to 1 degree of actual evap approach. So that looks good. I'm happy with that number. That looks like it's actually accurate. We're still pulling down. It hadn't been running for just a few minutes, but that's the number I'm looking for. So this one's done. I got another sensor on the other chiller. Let's go over. It's a entering water sensor, so let's check it out. So on this one, you can see our entering water is at 96, leaving 58. This chiller's not running right now. This is the redundancy. You can see it verifies right there. So what happened here is that entering water sensor has failed. So we're going to come up to view. We're going to switch over to binding. Let that go through its binding startup. Over to converter mode. So it's going to be this sensor here. This is our entering. One of the things I like to do is I like to do a LED verification. So right now it's identifying everything. It's getting pulled up. Let's wait for it to do all of its thinking. There we go. So from here we're going to go to there we go. So we got entering water. I'm going to do LED on. Click that. So earlier when we walked over, if you notice, that LED was off, and as you can see, it is now on. So that's exactly what I wanted to see. It's just something I do as a verification. That way I don't get anything crossed up or something crazy is not happening. So now that that's done, I'm going to unbind it. Going to kick over to unbind or unbound. Now I'm going to change it out, come back, rebind. Alright, so we've got the sensor changed out. I'm going to hit bind. It's going to pull up this little option. We're going to walk over here to the sensor. I'm going to take our magnet. LED comes on. It activates the sensor. Walk back over here. Hit yes, and boom. Now we can confirm it established connection. Hit LED on, and back to the sensor, and LED is on. So now we just need to go confirm that it is actually functioning. So we'll go back to unit view. Now it's going to recycle the operation on the controls, or on the control panel, and go through all of its self-diagnostic, self-testing. Once it does that, it'll reconnect automatically, and then we can come back and see how it's doing. Well, we've got a Carrier air-cooled chiller today. Got microchannel coils, I know everybody's favorite. And right there, that little black dot on the bottom, that is our leak. So just a tiny little pinhole. Hopefully it'll be a easy fix. Our local supply houses carry this AL 822 for aluminum, so I'm going to be using that today. Most of our supply houses don't carry any solder weld, sadly. I really like the look of their aluminum repair kit, but I don't have access to that locally. So anyway, that's our job for today. It takes about 50 pounds of refrigerant. So we'll get this repaired, get it back online, and see what happens. Got the TES 8 going. We got this repaired. So what I did was I took out this whole side bracket. To keep the bottom from sliding over, we just put a zip tie through there to hold it to the other coil so it'd stay safe. And then just got it soldered up. Went pretty smooth. Had a little bit of water trapped in here from the rain we had just yesterday, so had to boil that water out before I could actually get this to a proper temp. But yeah, overall it went really well. No complaints. I know it looks kind of dark, but Anyway, so pressure tested it, did really well, didn't bubble up or nothing. So we got the vacuum going. We're down to 1800 microns now and still pulling away. Hopefully we don't need it much longer.